everybody, Mrs. Bianchi. Joe walks on a treadmill at a constant rate. The equation below describes the relationship between t, the time he walks in hours, and d, the distance he walks in miles. So it's a little small, so I'm just going to rewrite the equation because it's really, you can't even see it. It says d equals 4 times t. And then they want to know which graph represents the relationship between the amount of time Joe walks and the distance he walks. So there's two ways that we can approach this. One way is to just take each choice, like let's look at choice A, and we want to think about x. See how x, the x-axis, they're telling you that that's time in hours, and then they're telling you that the y-axis is distance in miles. So if you were going to make one of these double T tables, you'd want to pay attention to how do they label the x, and how do they label the y-axis. And the function is 4t. So it's 4t equals y, right? Which they're calling d, because the distance is on the y-coordinate, just to clarify. So if we just look at choice A, and we ask ourselves, what's the ordered pair for this dot right here where my pen is pointing? The ordered pair for that would be over 1 up 4. So what we would do is we would see, does that fit this function of 4 times t? So we'll put the 1 here, and we'll put the y over here, and we'll see if this is true. So if we take 4, and by the way, I want to remind you that t is really x. So we could replace the t with the x, and it's the same thing. So if we take 4 and multiply it by this, do we get this? Does 4 times 1 equal 4? Now, before you say, oh, I think I found it, then you want to pick another point on the coordinate plane. So see this point right here where my pen is pointing? And again, I apologize how small it is. But if we asked ourselves, what's the ordered pair for that? It would be 2, 8. The x is 2, the y is 8. So let's substitute these values into this function to see if it works. So if I take 4 and I substitute in the value for x, which again is 2, do I get 8? And it appears that I do. So far, it's looking like A would be the correct answer. But I'm just going to separate a line here. We want to make sure we can eliminate some of the other choices. So if we look at choice B, we look at this one right here and ask ourselves, could this be it? Because A is looking like it's probably going to be it. And we take the points here. So let's take this point right here. The ordered pair for that is 4, and then that's got to be a 1. Now, if we substitute these values into this red expression, and we did 4 and substitute in this value right here, which would be 4, do you see how that does not equal 1? So that's how we would eliminate that as a choice, because right away, this dot that I'm marking in green, it doesn't fit the function. So then let's look at choice C. If we look at choice C, and how about we do that in a different color? This ordered pair right here is 4, 4. Now again, if we try this function of 4 and we substitute in the value for the time, which is the x, and substitute in this value, which is 4, 4 times 4 does not equal 4. So that can't be right. This is a no because of that. And then, of course, you'd want to look at this one. See, that's the same point. So if it didn't fit when we tried it for this graph, why would it fit if we try it for this graph? Plus, they give you this point, which is 4 and then 8. Now, again, if we tried that in the with the function and substitute that in, 4 times 4 doesn't equal 8. So the only one that seems to fit is choice A, but sometimes it's a good idea to just try to find another point, even though it might not land exactly, just to estimate it out. So there really doesn't seem to be a point that lands exactly. But even if we plugged in this one right here, that should fit. If we plugged in this one and used decimals or fractions, it should fit. So looking very confident that A is going to be your answer.